So amplitude is discrete, as well as we can take the value in discrete instant of time. That means we do not take the signal amplitude for every instant of time. Take the amplitude of the signal for a discrete instant of time. That type of signal is basically called digital signal. So digital signal means that is discrete in time and discrete in amplitude. That signal is basically called a digital signal. So you can also familiar with the different advantage of the digital circuit. If we process the digital signal by some circuit, that is basically called digital circuit. The example is a multiplexer, decoder, encoder, different adder, subtractor circuit, like different circuit. That is basically digital circuit. That is the example of digital circuit. So obviously that digital circuit has some advantage. So tell some advantage of digital circuit. What is the advantage of digital circuit?
Sir, less costly and super fast.
Less costly and super fast, less noisy. I think the digital circuit is not less noisy. Okay. Any other? We can also say that in case of digital circuit, we get some output data that can be easily stored. The storing capability is also better than analog circuit. We can easily store the data. We can easily store the output. And obviously that circuit can be built up easily, low cost. So for that reason, today is basically most of the circuit that we have been used, that is a digital circuit. But all the signal in nature, that is an analog signal. Say the voice signal. That is an example of analog signal. Say temperature. That is also an analog signal. So every signal that we have been get from the nature, that is basically the analog signal. So obviously, we need to know some circuit that basically process this analog signal. So for that reason, this subject is very important because most of the signal in nature, that is analog signal, then we need to convert the analog signal to digital signal. Then this digital signal can be processed through some digital circuit. Then we get output, and then this output is again converted into analog signal. So obviously some circuit is required in this intermediate process. And we can also use the different circuit to process the analog signal. So for that reason, this subject is very, very important, analog electronic circuit. Now, analog electronic circuit means that is basically processed at the analog signal. So the first question in mind, that is, what is analog signal? So analog signal means the signal that is continuous in time and continuous amplitude. That signal is basically called the analog signal. Say if we draw the waveform of the analog signal, these are the time and that is the amplitude. Say we can say that these are an analog signal, because every instant of time the signal have some particular amplitude, and amplitude can take any value. It is no matter, it will be take only 2, then 3, then 4, like this, like digital. So it can be take any values, and every instant of time. For that reason, it is called analog signal. So analog signal means it is continuous in time and continuous in amplitude. Continuous in time and continuous in amplitude. So that signal is basically called the analog signal. Say if we consider at t1 instant of time, if you take some value, we get some corresponding amplitude. Say these are the A1. Now we can let's say A2. So every instant of time we can take some amplitude. For that reason it is called analog signal. The example, speech signal, temperature signal, all the signal that we have been get from the nature, that is basically provided the analog signal. Now, if the analog signal that can be converted into a digital signal, then obviously we can take this signal will be discrete in time and discrete in amplitude. For that reason, the first circuit is required, that is called sampler. So if we need to use a sampler circuit by which we can sample this analog signal. So sampler is basically nothing but it is like a switch. Just we can connect a switch and this switch will be on off in a particular time duration, and the signal will be applied to the input of the switch. From the output terminal we get the sampled version of the input signal. So this input signal that can be applied through a switch. Now this switch that can be controlled by some, so these are the controlled by some input signal, and it can be on for a certain duration of time, then again it will be off, then again on, in that way. So it can be controlled by some signal. It can behave like a switch. This switch will be on, then the input signal that can be supplied to the output terminal, that is the input terminal, and in this input terminal we can apply this analog signal. In the output terminal we are taking the output signal. Then if the switch is on, the signal will be supplied to the output terminal. If switch off, then the output will be goes to 0. Again switch on, again the output signal is same as input signal. So in that way, if we take, say at t1 time the switch is on, for a certain duration of time the switch is on, then again it will be off, then in this portion it will be output will be 0. Again at the t2 time the switch is on, it can be on for a certain duration of time, then again it will be off. So we get this type of sampled version input of input signal. So that signal is basically called discrete time signal. Discrete time signal. That means that signal is discrete in time because we do not take the value of amplitude for every instant of time. We are basically take for a discrete instant of time, say t1, t2, t3, t4, like, and for a certain duration of time the switch will be on. For a certain duration of time the switch will get on, then we get some amplitude. So that signal discrete in time, but continuous in amplitude. So this type of signal is basically called discrete time signal. Discrete time signal. So discrete time signal is basically continuous in amplitude but discrete in time. Now after that, on the basis of logic, we have done the encoding, then we get the digital signal, that is discrete in time and discrete in amplitude. We have used some logic. Say we have already said that, say 0 to 0.5 volt, that can be considered as logic 0. 0.5 to 1.5 volt, that can be considered as a logic 1. 1.5 to 2.5, that can be considered as logic 2. In that way, we can use then that process is basically called encoding process. And using this encoding process, we can convert this discrete time signal into digital signal. So that is at that moment the signal is discrete in time and discrete in amplitude. So now in this syllabus we are basically discuss about this portion, that is continuous in time and continuous in amplitude. So if we need to convert any analog signal into digital signal or digital signal converted into analog signal, then we require one of the circuit, that is basically called analog to digital converter or digital to analog converter, ADC or DAC circuit. DAC circuit, AC and DAC circuit, analog to digital converter and digital to analog converter. Are you familiar with the circuit ADC and DAC?
Yes, sir. Yes, sir.
Tell one name of ADC circuit, one example of ADC circuit.
So flash converter, flash ADC.
Flash converter. So in flash converter, what type of electronic component we have been used? Basic component to build up this flash converter.
Sir, comparators.
Comparator means we are used operational amplifier. The operational amplifier that can be used as a comparator, right? So we are used operational amplifier. So these are basically one of the analog electronic component. Operational amplifier we have been used. In case of digital to analog converter, we are used R to 2 or ladder circuit or weighted resistor tag circuit. So in that case, we can also use operational amplifier. But in case of flash type converter, we are used operational amplifier as a comparator, and in case of DAC, we are used the operational amplifier as an amplifier. So that means the operational amplifier that can be used in the two different ways. Sometimes we can be used as a comparator, and sometimes we have been used as a amplifier. So basically, the circuit name is analog. Circuit name is analog to digital converter or digital to analog converter, and in this circuit we have used some electronic component. So one of the electronic operation, that is operational amplifier. This operational amplifier, the basic component of this analog to digital or digital analog converter, that is op-amp or operational amplifier. Operational amplifier. So this operational amplifier that we have been getting IC form. IC means integrated circuit form. So we have been get the amplifier that is in int form, that is very small in size, but it will be performed a different type of function. It can be used as a comparator, it can be used as an amplifier if we need to generate some test signal, because obviously if we need to build up some circuit, we need to test the circuit, that will be okay or not. So obviously in that case we are use some test signal. By using this signal we can testing the turn of the circuit will be done. So this testing purpose we are use some signal. Say we are use either sinusoidal waveform or we use square waveform. So we need to generate this type of input signal or test signal. So in that case we can also use the operational amplifier. That means we need to generate the test signal. Say we need to perform some mathematical operation like addition, like subtraction, integration, differentiation. So in that case, we can also use the operational amplifier. So a small IC chip, its cost will be very, very low. But using this small IC chip, we can perform the different type of function. But this operational amplifier is not a basic component of analog circuits. The basic component is transistor or diode. So inside this operational amplifier, we use large number of transistor. We can use diode, or we can also use some electrical component like resistor, like capacitor, inductor. So using this element, we are basically build up the operational amplifier. So integrated circuit, same like a assembly. Say if you need to assemble a computer, so first you can arrange hard disk, monitor, processor, keyboard, mouse. So everything that can be assembled and you can build up a computer. So same thing, we just assemble a large number of electronic components in a single silicon wafer. So in this single silicon wafer, we can fabricate So like a assemble of a computer. So in case of operational amplifier, we can also fabricate a large number of different electronic component like transistor, like diode, resistor, electrical component, resistor, capacitor, that can be just assembled in a single silicon wafer, and we can build up the integrated circuit. Now today, this fabrication technology is much and much improved, and due to the improvisation of the fabrication technique, we can easily fabricate a large number of electronic components in a single region or small region. So for that reason, the IC chip, its size will be comparatively less. If the size of the IC chip is less, then we can easily use this type of integrated circuit in different purpose. And this integrated circuit is basically used to perform a different type of function. So in case of operational amplifier, we've seen that can be used as a comparator, that can be used to amplify the signal. Amplifier means nothing but that is basically the multiplication of the signal by a constant term. Say if we use sine omega t, we can just multiply a constant term 5. Then at the output terminal we get 5 sine omega t. So amplification means just multiplication of the input signal by a constant factor. So we can use as an amplifier. We can use for different mathematical operation perform. We can done the operational amplifier. We can using the operational amplifier, we can build up the testing signal. So for different purpose, we are use the operational amplifier. So we need to use some integrated circuit. Now, in this integrated circuit, the basic component is a transistor or diode. So here use diode or transistor. So any idea about a diode or transistor? Any idea about diode or transistor? How many terminal in diode?
Two terminals.
Two terminals. What are the name of these terminals?
Sir, anode and cathode.
Anode and cathode. So positive terminal of the diode is called anode. And negative terminal is called cathode. That means these are a two terminal electronic component, diode. So before the diode, we are used vacuum diodes or vacuum tubes, but basically diode is the modern electronic component, and that can be used still now. We do not use the vacuum tubes now in that day, but we are used still now. We are used diode, and we use different type of transistor, different type of diodes we have been used in the different electronic circuits. Different classification of diodes will be occurred because that property will be different, and due to the different properties of the diode can be classified into different categories. Can you say some classification of diode? From the diode key classification jan?
PN junction, Zener.
PN junction diode, Zener diode. Or any other?
Sir, gun diode.
Gun diode, right?
Bracket diode.
Directed diode, very good.
Tunnel diode also. Schottky diode, sir. Schottky diode.
Schottky diode. Light emitting diode. That is another type of diode that can be provided the light. So different type of diode is possible, and obviously its property will be different. So PN junction diode that has some property. Zener diode, that is obviously the different property from the PN junction diode. Directed diode, that has also the different property. Gun diode, tunnel diode, that is also some different property. So obviously, due to the different property of the diodes, its application will be also different. So here we can say a switch. So diode can be used as a switch. So if we need to build up a sampler circuit, obviously we can use a diode as a switch. Now this diode can be used like a switch. Say sometimes we need to build up the diode using diode. We can basically build up the oscillator circuit. high frequency oscillator circuit, say gun diode, tunnel diode, that can be used for to build up the high frequency oscillator circuit also. So this circuit have the different properties. We are also know about a pin diode that can be used to generate, that can be convert the light signal, optical signal into electrical signal. That means from the light signal, it can be converted into voltage or current signal. So if we use pin diode, and again in the light emitting diode, we can convert the electrical signal into optical signal. That means electrical signal to light. We are use the directed diode that can be used as a variable capacitor. That can be used as a variable capacitor in case of different radio receiver. That means in receiver circuit, we as a tuning purpose, we are basically use the variable capacitor. In that case, we are use directed diode. So different diode, these have a different property, and on the basis of this property, we can use the diode for the different application. But one of the basic application of the diode, that is basically a switch. So as a switch, we can use the PN junction diode. Or another important parameter, so if we already know that we are used AC signal, but most of the electronic device that can be operated in a DC signal. So this AC signal that can be converted into a DC signal. Then obviously we require some circuit. What is the name of this circuit that
Rectifier.
convert the AC signal?
The rectifier.
Rectifier.
Obviously we are use a rectifier circuit. So these are one of the analog circuit where we can use the PN junction diode. So rectifier that can be convert the analog signal to digital signal. So in the rectifier circuit, we can also use the diode. So if we provide some AC signal, like this type of AC signal, that can be used in a rectifier circuit. And rectifier basically provide some pulsating DC signal. That is not a pure DC signal. That is called pulsating DC signal. These are full wave rectifier, or that is a half wave rectifier. We get this type of waveform, and after rectification, we get this type of waveform. So in rectifier circuit, one of the basic component is a diode. So this the electronic component that we have been used to build up the rectifier circuit, that is diode. These are the basic component. And the rectifier that can be basically convert the AC signal to DC signal. So these are one of the analog electronic circuit that can be convert the analog signal and from AC to DC. That conversion will be done. So now these are pulsating DC signal. That DC signal is not a pure DC signal. So what is a DC signal and what is AC signal? Any idea what is AC signal and what is DC signal?
স্যার এসি সিগন্যাল স্যার সেই সিগন্যাল যেটা মানে উইথ রেসপেক্ট টু টাইম ওটার ফ্রিকোয়েন্সির ভ্যালুটা চেঞ্জ হতে থাকে, আর ডিসি সিগন্যাল একটা উইথ রেসপেক্ট টু টাইম ফ্রিকোয়েন্সি কনস্ট্যান্ট থাকে।
Frequency and time, that is basically interrelated, right? So we can say that the amplitude of the signal that can be changes with time. Amplitude of the signal that can be changes with time. That is not a fixed. That is not a constant. But in case of DC signal, the amplitude of the signal is constant with respect to time. So here, if we see that the time changes, then the amplitude of the signal that can be also changes. But if we consider say this type of signal, here the amplitude is fixed. It is a constant with respect to time. Amplitude is constant with respect to time. So that is called DC signal. So for that reason, and the output of the rectifier is not a pure DC signal. That is called pulsating DC signal. So pulsating DC means that can be consist some AC plus DC. That does not a pure DC signal. So pure DC signal means that can be provide a constant signal with respect to time. with respect to time, its amplitude cannot be changed. But here in AC signal, the amplitude of the signal can be changes with respect to time. So it will be provided some pulsating DC signal, AC plus DC. So obviously, if we need to convert a pure DC signal, then we need to use some filter. By using the filter, we can filtering out this AC component. So obviously, the next circuit that is required, that is filter. So using the filter, we can basically filtering out this AC component. So filter is required. So I don't know which component is required to build up the filter circuit.
The capacitors.
Capacitor.
Resistors and capacitors. Depend what the component use of it.
Okay, so that means we can use either inductor or inductor capacitor or combination of these two L and C. So different type of filter we have been used. And sometimes we use passive filter, sometimes we use active filter. So if in a filter circuit, if we use some passive component, then obviously that is called passive filter. So what do you mean by passive component and active component? Any idea? Active circuit component and passive circuit component?
Sir, passive circuit elements are basically those only dissipates energy.
Yeah. That means example?
For an example, resistor.
Register. So that is basically the dissipate some energy, register. Okay. And store energy, dissipate and store energy. So like capacitor, like inductor, these are the passive elements. An active element that is basically generates some energy. That is called active element, like voltage source, like transistor, like we can also use this integrated circuit, that operational amplifier, because that can be also generate some signal. So these are basically used as a active element. So sometimes in filter circuit we are used also the active element. That means operational amplifier that can be also used to build up the active filter. So either we use passive filter, that means only using the resistor, capacitor and inductor, we can build up the filter, or sometimes we are use only inductor and only using inductor, capacitor, as well as we can also use some active element like transistor or like operational amplifier. We can build up also the filter. That is basically called the active filter. So we can build up the different type of filter. That is another example of analog circuit, the filter. So using the filter, we are basically filtering out the AC component, and we get near about DC component with respect to time. With respect to time, we get near about DC component. But after that, in this circuit, if we connect a load, if the load is connected, then that load is basically that is changeable. That value changeable. Sometimes we can connect a 50 ohm load. Sometimes instead of this 50 ohm load, we can connect some reactance. That means we can use some capacitor or inductor as a load. So that means, or sometimes we can use the combination of resistor or capacitor. So that means the load that can be variable. And due to the variation of the load, we seen that the output voltage cannot be constant. That can be changes due to variation of load, or due to the variation of the supply signal, because here we can use some AC signal, its amplitude is also varied, that supply signal is also varied. So due to the variation of supply signal or due to the variation of the load, the output of the filter that can be also changes. That means the output voltage that cannot be constant with respect to time due to the variation of the load or due to the variation of the input signal. So in that case, we require another circuit to maintain the constant voltage with respect to time due to the variation of load as well as input signal. So that circuit is basically called the regulator circuit, voltage regulator circuit. So we need to use a voltage regulator. We need to use a voltage regulator circuit, and that is another example of analog electronic circuit, voltage regulator. So this voltage regulator circuit that can be maintain the constant output voltage due to the variation of load and due to the variation of input signal. So in this voltage regulator circuit, we need to use some electronic component that is basically regulate the voltage. Or you know what type of component we have been used to build up the voltage regulator?
ট্রানজিস্টর ইউজ করতে পারি।
Transistor, obviously there is a transistor that can be used for voltage regulation purpose, but that is not a basic component, but that means we can say that a basic or essential component means that is required to build up this circuit. That is required to build up this circuit. That is Zener diode, right? That is a Zener diode. That is the essential component. Obviously, we can also use transistor. That is transistor-based voltage regulator circuit. That can be some advantage than ordinary voltage regulator. That will be discussed later. So, but basic or essential component, that is Zener diode. In case of Zener voltage regulator circuit, we have been used Zener diode. That is essential component. We are used transistor. We can sometimes we are also use operational amplifier to improve the voltage regulator circuit. But the essential component is Zener diode. So here the electronic component that we have been used, that is Zener diode, basic component, and this Zener diode is basically used to build up the voltage regulator circuit. So these are the example of analog electronic circuit. So this total circuit is basically called a DC power supply. That is a block diagram of DC power supply. So we can build up a DC power supply, but inside the DC power supply, we are seeing that the three different analog electronic circuit is present. One is rectifier, filter, or voltage regulator. Now, if we need to judge this DC power supply, we need to test this DC power supply, that is okay or not. We can check this circuit. Say we can build up a power supply, that power supply is okay or not, that can be checked. So obviously we need to apply some test signal. So that means here we can apply some AC signal. That AC signal, here we use sinusoidal waveform. So this sinusoidal waveform that need to be built up. We need to use this sinusoidal waveform. So this sinusoidal waveform can be built up using some circuit. So can you know the name of this circuit by which we can build up the waveform, this type of sinusoidal or square or any other waveform that can be built up? Are you familiar?
Function generator.
Function generator. Obviously, these are the function generator. In the lab, we are basically using the function generator. We can provide it the input signal. See the function generator as an input that can be used to generate the different input signal. Using the function generator, we can build up sinusoidal waveform. We can build up rectangular waveform or square waveform. But the circuit name is function generator. Is basically this instrument name by which we can produce the input signal to the lab. But the main circuit inside the function generator that will be present, that is called oscillator. So using oscillator, we can basically build up the test signal. We can generate test signal. Oscillator. So it is one of the analog electronic circuit. By using the oscillator circuit, we can build up the test signal. So this test signal is either